Katrina here, and welcome back. Today we're going to start our discussion on limits. So we're going to ask ourselves, what is a limit? So when we think about limits, we think about approaching a value of a function without actually getting there. So that might sound a little bit funny, but it's a good practice in calculus because oftentimes we can't actually reach a certain point, but we want to look at a behavior that exists around a certain point and see how does our function behave. So when we think about limits, we need to look at limits from both the right-hand side and the left-hand side. So say, for example, by looking at this plot over here, we want to look at what is the behavior around the point where x equals to 2. So we're going to approach our function from the right-hand side over here, and then we're going to approach this point from our left-hand side. So let's see mathematically what we get. So when we approach 2 from the right-hand side, we're going to be looking at a number around, let's say, 2.0001 as an approximation. So what is the value of our function when x equals to this number? If we follow our graph, we can see that our function equals to about 4. So now if we were to look from the left-hand side, we're going to use an approximate value of, let's say, 1.9999. So what is the value of f of x at this number? And we can see here from the plot that it equals to 4. So we've actually just solved our very first limit together. So let's write this together in proper limit notation. So that means that the limit as x approaches 2 of our function f of x equals to 4. So now let's look at a few of the conditions that we have to have in order for our limit to exist. So first of all, our limit has to approach a single value. If it approaches multiple values or an undefined value, then it does not exist. Secondly, the limit of f of x as x approaches a exists if and only if these following three criteria are met. First of all, the limit as x approaches a from the left-hand side, indicated by this minus, has to exist. In parallel, the limit as f of x as x approaches a from the positive side, which is the right-hand side, also has to exist. And furthermore, not only do these two sides have to exist, but they have to equal each other. So in our first example over here, we can see that the limit from the right-hand side equals to 4, it exists, and the limit from the left-hand side exists and also equals 4. Since these two values equal each other, that means that our overall limit over here exists. Let's do another example. So what happens if we were given that the limit as x approaches 1, let's say from the left-hand side, equals to 4, but then the limit as x approaches 1 from the right-hand side equals to -4. So in this case, the limit of the left-hand side exists, and the limit from the right-hand side also exists. But the issue is they don't equal to each other. So since they are not equal, then that means that the overall limit does not exist. So you might ask yourself, what does this look like graphically then? So this is indicative of a piecewise function where we have some sort of jump discontinuity. So say at our point 4 over here, we have a value up here, and remember our a value equals to 1, so 1 is our a value. And then we might have another value over here. So say we have some function that looks like this. We can see that as we approach 1 from the right-hand side, we get a value of -4. And then as we approach 1 from the left-hand side, we get a value of +4. So even though the individual one-sided limits exist, we can see that the overall limit does not exist because they do not equal each other. So again, this is a great way to figure out if you have a discontinuity in your function. So here we've got a jump discontinuity. And that's it. You've learned how to solve your first limit. If you enjoyed this video, please drop a like and comment any questions that you have. Let's solve more fun and exciting math videos together, and please subscribe. I'll see you next time.